I'm going to do the 2024 question first, and then we'll do the other ones later. All right, so hopefully we knew what was going on. All right, so I'll just read the question. The diagram shows a simplified version of the process of polypeptide synthesis. Compare process A with DNA replication. Now, the first thing we do, right, we look at the Nessa verb. What is the Nessa verb saying? Can someone tell me? Compare, right? Yeah, okay, cool. Thank you, River. Right, similarities and differences, right? So please don't forget similarities and differences, right? This year, HSC had like compare like 5 times. So you know what? If you didn't do similarities and differences, that's 5 marks you could have lost, which is, that's a lot of marks, right? You don't want to do that, right? So compare is similarities and differences. So let's write that down. All right, now, we'll chat about this. What are some things that happen in polypeptide synthesis that also happen in DNA replication? What's some things that they have similar?
Produce another strand.
That's true, yeah, I guess a new strand is made, right? But technically it could be different because one's making RNA and one's making DNA, right? Yeah?
They both require DNA as their form of genetic material to create.
Yeah, okay, yeah. So both use DNA as a base for before transcribing or replication happens. Yes, Natalie? Yeah, okay, yeah. DNA is unwound in both. That's pretty good. Yes.
Polymerase.
Yeah. So a polymerase is what actually attaches the nucleotides, right, in the sequence. Yeah, that's good, right? So anything else? Hydrogen bonds breaking when the DNA unwinds. Yeah, you could mention that too, right? So that's pretty good, right? That's pretty good. So for similarities, we could do any of those things. We should probably, it's 3 marks, so I wouldn't just say 1 similarity, 1 difference. 1 mark here. Both processes, right? Now it's important here you don't say unwinding via helicase because there's no helicase working in transcription, right? The polymerase does the unwinding. So just say that it's unwinding. Process A, okay, what else? DNA unwinding. What are some other things I can say? I can also mention my difference now. So RNA made versus DNA, right? And I could also mention that maybe the RNA is complementary while the DNA is identical in DNA replication, right? So you could talk about a bunch of things. Yes, Arya?
What does it mean RNA is complementary?
Because the strand you make is complementary to the strand of DNA. It's not exactly the same, right? Because the uracil is replaced and it has to match. So it's not an exact copy. Whereas in DNA replication, it should be an exact copy.
Okay.
Yeah. Cool. All right, let's keep going. All right, explain the importance of mRNA and tRNA in polypeptide synthesis. This is 5 marks, so it's actually a pretty big, chunky question. So before I go through it, right, so it's explained, so we need to say basically what they do, and we can't just describe what they are, right? So what I'll do is I'll just chunk it into mRNA and tRNA, and then we can just write some things about each. I know I'm drawing it side by side, but we're not comparing them, right? So what are some facts you can tell me about mRNA? Where do we get it from? Yes, Han? Yeah, okay, so I'm going to say transcribed from DNA, and then it goes out of the nucleus, as you said, into the cytoplasm. Right? Why else is mRNA so important? What do we need it for? Right? Yeah, we need it for the codons, right? It's important because has codons. And what do codons do? What do codons do?
Get red.
By the
Yep, which are read by ribosomes.
code for the amino acids.
Yep, read by ribosomes to code for amino acids. Right? Yeah, so this makes polypeptides. All right, now, what's so good about tRNA? Why is it important? What do we need it for? What does tRNA have? Yes, Arya?
It reads well, it gets added and then gets the amino acids.
Okay, yep, so tRNA actually like carries / attaches amino acids, right? Right. What's the complementary word to a codon? What's the other way of, what? Anticodon, right? Has anticodons. Which match to codons. Right. What else should I say?
The importance of proteins.
The importance of proteins.
Like, you need mRNA and tRNA to make proteins.
Oh, yeah. Yeah, that's true, right? Yeah. So without these, so without tRNA, I'll just say no amino acids, therefore cannot form proteins. All right, cool. Yes, Lucas.
Can we answer the questions in the text and use dot points?
Yeah, you can. You can answer however you want. This is not English. Yeah. Most people choose to write it out, but yeah, answering it like this in dot points is completely fine. Yeah, it's completely fine. Okay, cool. I might mention somewhere here in this response that this process all falls under translation. Yeah, I think that's necessary. Otherwise, you might lose a mark. Yeah, just mention that these are important in translation, just as this stuff was transcription from earlier. All right, let's do